Okay, I think we are live. Hello, everyone, and welcome to How to Leverage Intercanopy Lighting with Cannabis, presented by Fluence. This is our second webinar of 2024, and we're thrilled to have everybody here with us today. My name is Tim Kopp, and I'll be your moderator for today's session. As cultivators, owners, and operators in the cannabis space, we all recognize how vital it is to be able to make data-driven decisions when it comes to the success of our business. Staying ahead of the curve often requires a mixture of forward thinking, curiosity, and innovation. To achieve our business goals, striking the right balance between quality, yield, and potency is more important now than it ever has been. As growers look for strategies that can improve their financial performance and give them a competitive edge, one topic that's been gaining a lot of traction in recent years is the idea of introducing more light to the canopy, where traditional top lights or even sunlight can have a difficult time penetrating. We already know that adding more light has a direct connection to more yield, but are we missing an opportunity to get a more consistent yield by neglecting to light the area below the canopy? Segments of commercial agriculture have been employing ICL strategies for years with certain crops such as cucumbers or tomatoes. Do these same strategies translate to cannabis? If so, how and to what end? In today's webinar, we'll be addressing these and other questions by looking at a collection of customer trials as well as our own internal research on the potential benefits of ICL. We have a host of panel speakers on the panel with us today, including three members of the Fluence Crop Sciences team, led by Dr. David Howley, Principal Scientist at Fluence. Also have Brian Pohl, who is Fluence's Cannabis Research Manager, and Dr. Jason Matlock, our data scientist and communications expert at Fluence. Guys, thanks for joining us today. We'll be drawing on Dave, Brian, and Jason's wealth of knowledge, and they'll be providing their insights by examining their approach to how ICL may be a winning strategy for cultivators looking to maintain that edge. Also with us today is special guest and Fluence customer, Mike Palulis. Mike is CEO and founder of Echo Creek Farms, a diversified and certified organic farm out of Salem, New York. Mike will share his experience bringing supplemental lighting into the greenhouse, starting with HPS, moving to LED, and more recently introducing Intercanopy Lighting. Welcome, Mike. Dave, Mike, Brian, Jason, thanks again for the time today. Before I turn it over to you, Dave, I would like to invite everyone to ask any questions they might have using the Q&A chat box that you'll see, hopefully a button for up in your right-hand corner of your screen. We'll be leaving time at the end of the session to address everybody's questions. And with that, I'll turn it over to Dr. Dave, who will start us off by letting us know what ICL is and why it may be a great tool for growers. Dave.
Thanks, Tim. Yeah, so hi everyone and welcome. I'm going to start really simple and I'm going to move it on to Jason and Brian really quick to tell you all about the research we've done, but let me lay the groundwork first. So intercanopy lighting, very simply, what is it? It's the idea of introducing light down into a plant canopy, and that can be thought of as maybe redistributing some of your top light energy from the top of the canopy down in the canopy, or it can be thought of as adding light down into the canopy. Now, let me acknowledge right away, this is not a new idea. We did not invent this idea. This is relatively old news in the world of commercial agriculture, particularly in high wire vine crop production, where you have these really tall tomato and cucumber plants. And the technology potentially is viable in any crop where you have a really dense canopy, and you might have lower canopy leaves that really aren't doing much, and they really should be. So, with that in mind, let's say, why might you do this? Well, the thing is, any crop that you've grown, you are inherently investing in solar panels, right? If you think of plants as these little factories that we have kind of manipulated to our needs to produce whatever it is that we want to produce. You know, whether it's a tomato fruit or whether it's a cucumber or whether it's a pepper, pardon me, or if it is a cannabis inflorescence or bud, for lack of a better term. Now, leaves really are the solar panels of that factory that are collecting energy and then transferring that energy into sink tissues. And any investment you've made in terms of your time, your energy, your fertigation, your nutrients, your water, any investment you've made to producing those leaves or producing those solar panels is wasted if you don't get energy out of those solar panels to produce more of what you actually want to sell at the end of the day. So, if we think about this, based on what we've seen in other crops, right? It's really about adding light to solar panels that aren't working very hard already, right? And if you think about cucumber, if you have a lot of light at the top of that canopy, those upper leaves may be close to photosynthetic saturation. And that's what I'm illustrating on this graph right here. You can see, for instance, that at 250 micromoles, where people typically are lighting cucumbers, we're at this inflection point where as you add more light on the x-axis, your relative yield that you get back starts to plateau off shortly past 250 micromoles. Cannabis is a little bit different, right? On average, this isn't everybody, but on average, a lot of people are using supplemental lighting of 1,000 micromoles per meter square per second in cannabis. And there's still quite a bit of headroom you can see here where you could add light and get a proportional increase in yield back. In other words, for every 1% light that you add, you're going to get 1% yield back. And that's going to be really important. We're going to elaborate on why this is really different in cannabis versus cucumber toward the end of the presentation. The point is, there's reason to believe that intercanopy lighting in cannabis could be valuable, but maybe not as valuable as what we see in other crops where the top of the canopy is close to photosynthetic saturation. So hold that in your mind. This is a really important nuance of something that makes cannabis so unique, is that it's just so hungry for light. Intercanopy lighting maybe adds value, but maybe isn't as critical as it could be in other crops. So lastly, before I pass the buck here, something to bear in mind is that what we're trying to do with intercanopy light is create a more homogeneous light environment. And this is one of those things about plant development, regardless of the crop. If you create a more homogeneous production environment, whether that be your temperature, your lighting, your nutrition, you will inherently have a more homogeneous crop. In today's market, quality and consistency are critical. So that's one reason why we want to explore intercanopy lighting and share with you today what we've learned. Lastly, there are other interacting factors, of course, how you space your plants and everything else. Those are all going to come into play. So don't take this as a silver bullet that just you do this and leave everything else the same. It doesn't work that way. Before we dive into Fluence's research for the last couple of years, I thought it'd be fun to point out, what does the prior research suggest? Well, fortunately, there was some guy named Dave Hawley that in 2018 published a study called Improving Cannabis Bud Quality and Yield with Sub-Canopy Lighting. And in this context, you can think of sub-canopy and intercanopy as somewhat interchangeable. There's some nuance there. But what did we learn in that study? Well, what I highlighted in yellow here is overall, both of the sub-canopy treatments significantly increased yield. And in these graphs, you see an increase in yield with the treatments and an increase in harvest index. So based on this, you'd say, well, great. That must mean that intercanopy or subcanopy is just best for everybody all the time. But here's the thing. I'm that same Dave Hawley, by the way, so I'm not picking on anybody here other than me. If that study was done in 2018, why did we not just commercialize a product to do this back then? And the truth is, because the reality is that one study is only one study. It was a well done study. I'm proud of it. But the fact is, I would certainly not do one study that was true in only a couple cultivars in one lighting situation and then say, well, that must justify a commercial product. That's going to be true for all growers, because that's not how it works, right? This is one of the inherent barriers of academic research, is that it's true in that particular case, but not necessarily big enough to make generalized conclusions and then productize in a commercial environment. So had a little fun there, but I think the magic of Fluence research is that we do a lot of research before ultimately telling you how a technology may or may not be right for you. And with that in mind, I'm going to turn it over to Brian Poole, who runs our cannabis research, and he's going to tell you about what we have done in-house. Brian, take it away.
Thank you, Dave. There we go. Excellent. So what I'm going to do is I'm going to go over 3 of our internal research projects that we executed in conjunction with 2 of our research partners. So I'll start off. The first thing we looked at was ICL spectrum. So what's the optimal spectrum or color of light to move inside the canopy? And we executed this with our research partner, Texas Original. They're located just south of Austin, Texas, not too far from Fluence HQ. So what we looked at in this case was we wanted to start with 4 different spectra. So we delivered a top light background of 1,200 micromoles per square meter per second, and then we had 4 spectra delivered via ICL. Each of those was approximately 300 micromoles per square meter per second. And that kind of works out to 566 micromoles per second over a 20 square foot plot. And those treatments were a broad white with far red, a pink treatment with about 60% red, a high red treatment with about 90% red, and then the full-on 100% red. So we looked at Blue Dream in this case. We've got a lot of historical research on it. We've been using that cultivar for about 4 years, so we really know how it performs under different conditions. And then down at the bottom there, we've got our random factors, and these are things that we pay attention to because they may provide some plant-to-plant variability in addition to those actual treatments themselves. So on the right there, I've got the schematic of the layout. We replicated this 4 times throughout the year, and this was in indoor conditions. And this is kind of what it looks like with the top light shut off. You can see our increasing spectra as we go from right to left there with the broad white with far red all the way up to 100% red. Because I'm going through 3 experiments quickly, we'll jump right into the results for this one. So with respect to spectra, we didn't see any difference in terms of height or dry floral material with the different spectra going up to high red. Additionally, when looking at cannabinoids and terpenes, there were no effects of spectrum. Again, one thing we do see is that as you go from the bottom of the canopy up to the top, you usually see an increase in total THC and total terpenes, but there wasn't an interaction with the spectrum we delivered. The other thing we saw is that when we got in those really high red treatments, the 90 and 100% red, we saw photo bleaching. So down in the canopy where this light was delivered, we saw bleach bud at the end when we went to harvest. So putting all those things together, it's nice to have high red because of the efficacy. Therefore, you have a lower energy input and lower cost of running those fixtures. But with the photo bleaching, essentially what we determined was that the broad spectrum, the BP6, the more pink light with about 60% red, was kind of the optimal spectrum, balancing efficacy and the lack of photo bleaching and maintaining yield. So that would be the optimal spectrum to move forward with for intracanopy lighting. So the next thing we're going to look at is distribution in a greenhouse. So how much of our light should we be moving inside the canopy? This was done with our research partner Inexo in the east of the Netherlands in Metternich. And I think I see Dominic Van Gruzen there in the attendees. And so he played a large part in executing that. And so because this was done in a greenhouse, we replicated this 4 times simultaneously. You can see the layout there on the left, making sure that we're randomly distributing the treatments. The treatments in this case being 800 micromoles of top light alone compared to ICL. So we're taking 1/3 of those photons and moving them inside the canopy. So 533 micromoles of top lighting per square meter per second, and then 267 micromoles via ICL. And this is run, 12 hours a day for our short day crop. Because it was done in the winter in Northern Europe, essentially we're getting, 1 to 2 moles on average of ambient light. So really ambient light's not a strong contributor to the total flux in this case. And again, we can see the layout here in the greenhouse. We've got our 4 simultaneous reps. You can see the ICL bars there on the left and the top light alone there on the right. And for this case, we went a step further. We'll look at total yield, but we also broke things down into grade, our class A's, B's, and C's, or our large and smalls and trim waste. We'll get into the grading results in a second. But first off, what we saw was looking at total flux, so top light and top light plus ICL for all the marketable flower material, we don't see a difference in total yield. So with equal flux to the canopy, we're seeing generally equal yield. You might look at that and see a bit of an increase, but when we run statistical analysis, we see that there's not enough evidence to say that, yes, there's a difference between these 2 treatments in the commercial cultivar on the left. That's the name of the cultivar. And then in the skunk cultivar there on the right. So in this case, we're not using ICL to increase our total yield. But when we look at breaking it down by grade, so in this case, we've got our class A's, our class B's, and our C's and waste. And on each case, we've got 1 cultivar on the left and 1 on the right. So starting off looking at our A bud, we do see an increase when delivering light via ICL in the commercial cultivar for our A buds. When looking at our B buds for the skunk cultivar, we're also seeing an increase in B buds. Now, because we're not increasing total yield, where is that coming from? And if we go over and look at C's for both commercial and for skunk, we're seeing a decrease in our Cs, or our waste. So essentially what we're doing for these two cultivars is moving Bs into As and Cs into Bs, or in the case of skunk, moving our Cs into Bs. And so what that does is it increases the overall value for the canopy together. Again, when we look at our cannabinoids, we're not seeing any difference when we deliver ICL. So in this case, we've got our commercial cultivar, and it's that same trend. Lower down in the canopy, less potency. And as you move up, you see higher potency. But we're not seeing an effect of ICL distribution in this case. So our conclusions are, again, we're not affecting total marketable yield, but we are improving the overall profitability of the canopy by moving Bs into As or Cs into Bs, or both. And we'll see the trend as we go that ICL is not affecting cannabinoid concentration anywhere in the canopy. And so the last thing I want to look at is a similar distribution style experiment done indoor, again with our partner, Texas Original. And so in this case, this was part of a larger project, but I want to focus on 4 specific treatments. So we delivered on one side for replication, we delivered 1,100 micromoles per square meter per second, and a higher light intensity of 1,400 on the opposite side. And then in each case, we supplemented with either 0 bars or 4 bars of ICL. So what this does, it gives us 4 different treatments with increasing flux, but we can also look at these 2 treatments with similar flux, the low top light with high ICL and the high top light with no ICL. And so what we see in this case is as we increase our total flux, we're increasing our marketable yield. But if we look at these 2 similar treatments, or these 2 treatments with similar flux, we're not seeing any difference in yield. So similar to our greenhouse experiment, we're not seeing an increase in yield just by moving light inside the canopy. Same total flux means same total marketable yield. Breaking it out by grade, so similarly to what we saw, or I guess a little conversely to what we saw in the greenhouse experiment, when we look at our A bud in the top light alone, or top light plus ICL versus top light alone, we're not seeing any significant differences in A bud, or differences in B bud, or differences in C bud in this case. So the reason these can be conflicting is, we're looking at 2 different production styles. We're looking at 2 different, I guess in this case, 3 different cultivars. So we're seeing conflicting results, and we can only look at so many people. We can only look at so many production styles and cultivars internally. So where does that leave us? So one thing we can kind of conclusively say is we're not seeing an increase in yield when we deliver the same flux, just moving it inside the canopy. There is a potential to increase in grade, but we saw conflicting results. What we need to do now is work with external growers and say, hey, here's what we saw. Let's try deploying ICL in your facility with your cultivation styles, your pruning methods, environment, and cultivars, and what are your experiences? And so Jason Matlock, who's going to speak next, will execute those trials, and he's going to present what we've seen so far. And so with that, I'll pass it off to him.
Thank you, Brian. All right, so as Brian mentioned, in the research world, our primary goal is certainty. We have replication and strict control of confounding factors. And our goal is to make concise conclusions about the very specific results that we observed under those highly controlled conditions. Oftentimes, research is limited by space and time when there's only so much that can be tested in that way. So it's a really great way of getting started and pointing the path that we need to follow. In commercial field trials, our goal is exposure. We want to encounter as many different environments, cultivars, practices, and fixture deployment methods as possible so that we can understand broad trends and capture the range of possible outcomes. We're not necessarily focused on the results of any one single trial. Instead, what we're trying to do is aggregate data and see what happens when we look at multiple trials collectively. The ultimate goal here is to have confidence in a product and to be able to communicate reasonable expectations and field-tested advice to our customers. To that end, when we look at Vine, which is our Intercanopy fixture, we can see that there's actually several use cases for this product. You can use it indoor. You can use it in a greenhouse. You can have high or low or even no top light. You can have different amounts of light in the inner canopy. So there's a lot of variability when you're trying to consider what is necessary to answer questions like what should I expect to see and what is the best way to deploy ICL. Recognizing the need to capture this variation, we've deployed trials across a wide range of operational styles. Currently, we have 8 active trial locations, and I have data in from 5 of them. In these trials, ICL flux was between 10 and 35% of the total light delivered to canopy. So while each of these locations is different, we've also tried to standardize the way that we collect and report data. So while we have a lot of variation to cover across site to site, which allows us to capture variability, by standardizing our methods, we can then standardize the way that we communicate about those results. It also allows us to integrate the results and explore general trends in a way that is statistically meaningful. Because of this, we can draw more robust and justified conclusions than we would otherwise considering several trials, and each of them being conducted differently, and then trying to guess what's going on. So what I'm getting at is that ultimately our goal is to look at sort of a meta-analysis to inform what broad trends are, rather than looking at a set of individual trials and saying, hey, this trial said A, this trial said B. So real quick, just an overview of what we did and what these standardized methods were. So the first thing we did was we collected data at the harvest level. So for each cultivar by lighting combination, as an example, animal cookies top light versus animal cookies ICL. For each of those, we measured the yield that came out of that combination. But we took it a step further, and within each of those combinations, we further sorted them by grade. So for each grower that we worked with, we had slightly different grading styles, but they all kind of broke down into 3 bins: A, B, trim, big, small waste, market, pre-roll, extract. Ultimately, everybody was differentiating based off of the value of the fraction, right? Large, dense nugs go to flower market. They command the highest value. Smaller material that's still reflective of the flower goes into small bags or pre-rolls, and then the remaining material is either wasted out or goes to extract to produce concentrates. So we tracked each of those fractions similar to the way that Brian did in his experiments. Our goal is to understand how ICL affected the allocation of flower to each of those bins, so that we can ultimately evaluate whether there's an effect on the total value of the harvest. As Brian mentioned, if we produce more of the higher value material, then that same harvest is worth more than if that distribution was different. So in addition to looking at the total harvest and its bins, we also looked at individual flowers. And what I wanted to understand was how ICL was affecting variability at the flower level. So for each of these cultivar by light treatment by grade bins, we sampled out 30 discrete flower buds randomly. And then we looked at mass, size, density, and potency for each of those individual flowers. For the potency measurements, we actually used a device called the Purple Pro, which is a near-infrared spectrometer that's specifically designed to measure THC in ground flower. And it's actually fairly accessible. So if there's any growers out there, I will say that this was a really useful tool. Each individual measurement isn't necessarily as precise as a lab-grade component, but when you take that kind of sample depth, you can actually converge on a very accurate estimate of what your crop is doing. So now that we've kind of talked about what we did, we'll take a look at the results. The first thing I want to do is I want to start with a study case that demonstrated what we would consider to be sort of the most substantial improvements, kind of our best case scenario. And this helps establish an upper bound for setting expectations when considering ICL applications. After we've kind of gone through the best case, then what I'll do is take a look at the general trends that we see when we aggregate all of this standardized data together. So here's our best case. This was done with Light Sky Farms in Michigan. These guys are an award-winning brand. They're known very well for the quality of both their flower and their extract products. They've won a number of awards, including the ZA Olympics last year. This is an all-Fluence LED facility. They've been recently spotlighted in a number of articles and videos that we've worked with and put out recently. They came to us and said, hey, we're a great grower, getting great results. How can we push this even further? And the answer that we had was maybe with ICL. So when we looked at that question and we tested ICL, what we found was indeed we can in fact improve things even further than great. So when we looked at their trial, what we did is we standardized at excuse me, at 900 micromoles, and in both ICL and in the top light, they had the same flux. We moved a third of that light into the intercanopy for the ICL treatments. From a result standpoint, first thing we saw is that all cultivars showed an increase in A-grade bud. That was accompanied by a decrease in trim. Collectively, when we look at all three of the cultivars that we tested, we saw that A-grade went from 37% in top light to 50% of the harvest in ICL, and that trim decreased from 35 to 26%. We also saw greater yields in all three cultivars, and this is really interesting because unlike Brian's study, what this means is that for the same amount of light, we actually produced more product. So we made a more efficient use of light, more yield per unit photon. When we look at the cultivars, this increase ranged from 4.3 to 10.6%, with an average increase of 7.5%. Furthermore, with respect to individual buds, the size remained approximately the same, but the mass of the A-grade buds was greater, which means that we increased their density. We did not, however, see any change in THC. So the takeaway from this study is that ICL increased bud density, it reduced the number of large flowers, it reduced the amount of trim coming off of each flower, and it promoted B-grade to A-grade buds without changing potency. So when we look at this general narrative, the pattern is followed when we start to look at aggregated data. This is a compilation of 5 facilities, 3 greenhouse, 2 indoor, representing 11 cultivars. The big take home for ICL here across all of our studies is that ICL enriches A-grade bud and it decreases trim and waste fractions. Across the 5 studies, we saw in general an average change of about 9% in A-grade bud when adding ICL, accompanied by a 17% decrease in trim. The other big take home for ICL is that the cultivar became the most significant factor affecting response. We saw a lot of variation in every study between cultivars when we had multiple studies, or excuse me, multiple cultivars in each study. So what this tells us is that as a whole, as with any horticultural practice, it's really important to look at cultivar selection and to consider your growing methodology when you're performing pheno hunts in cannabis. So if you want to use ICL, select for cultivars that are going to perform the best under ICL. Ultimately, what we've observed is that yield responses to ICL are similar to top light. When you add light, yield increases proportionally. There may be some cases where, like in light sky, light use efficiency increases, but that doesn't seem to be the norm. Still a possibility, but we would expect yield to be yield when adding light. However, we would never expect yield to decrease. Finally, when we aggregate the data, it also lets us look at some trends in uniformity. So I have these graphs over here. What we did is we looked at the smallest to the largest in terms of bud mass and bud volume. And when you kind of look at that distribution, big box means that there's a big spread between largest to smallest. Small box means that there's a little spread between smallest and largest. As cultivators, we want to have the most uniform crop, aka we want to have the smallest box. So when we look at this, we see that for both mass and for volume, there is a smaller box for ICL. That means that we're reducing variability in the whole crop. In mass, it's an 11% reduction. For volume, it's a 9% reduction. When we looked at THC, both in terms of absolute potency, average potency, and in terms of uniformity, we really don't see a big change. So once again, THC doesn't seem to be affected. Now, one other value of doing multiple studies is that sometimes you learn about things that you didn't necessarily set out to learn about. And indeed, in this case, we encountered some unique use cases for intercanopy lighting that help us sidestep one of the classic issues that we've encountered as PPFDs have gotten higher in top lighting and cannabis. So to understand that, we need to spend a little bit of time talking about how cannabis responds to top light. With each cultivar, this pattern varies slightly, but there's a general trend. So at first, as we add light, there's a linear response. More light, more yield, 1% equals 1%. Then there's a point where we still get a response, but it starts to curve off a little bit, and we're still making money by adding light. Eventually, you start to see a point where maybe you see a yield response, but you're not making any more money. So it doesn't make sense to invest in it, or it makes growing harder. And ultimately, you can add so much light that you damage the plant. Now, there's another thing that happens in cannabis. There's a point in some cultivars where you may be able to add additional biomass, but the morphology of the plant changes, and it can change in a way that is undesirable or reduces its value. So while you may be able to yield more, you might actually make less money because you're changing the value of the crop through changes in its appearance. And a lot of times, if you look here at these three photos, you can see this is kind of what we're looking for, this standard flower. But we can see re-vegging or foxtailing, and there's a number of other examples. But both of these are things where we are making less money off of that product, even if we can grow more of it. However, light responses tend to be highly localized, and they mostly manifest in the top colas. So while the top cola may be maxed out, the bottom still has plenty of room under the pedal. And so there's a strategy where in photosensitive cultivars, we can move light into the intercanopy, take advantage of yield response by adding more light into that relatively underutilized material, but avoid the negative morphology that comes from utilizing high intensity at the top. And indeed, we were able to do this in a number of photosensitive cultivars and achieve increases in yield. So kind of a cool finding. So ultimately, when we kind of pile this all together, what do we see? Key takeaways. First, in terms of yield, again, we're expecting that as you add light, you add yield, and that's generally going to be similar to top light. However, there are some cultivars that seem to be well disposed to ICL, and in which case we may actually gain more than we would by adding top light alone. In terms of the value of the harvest, aka the harvest index, we're enriching the value by having more A-grade flower, reducing waste to trim, but that the results vary with cultivar. In terms of bud morphology, A-grade buds in ICL are about the same size as they are in top light or larger. So we haven't seen anything where we've had a negative impact on morphology. But we have also increased bud density in ICL. And that's promoting buds up to higher and higher grades. And then finally, as we just talked about, we have this unique application where we can extend our light yield response in photosensitive cultivars by using ICL to add light to the inner canopy and avoid those morphological issues. Now I want to pivot and talk a little bit about who's going to benefit from this. The place to use this is when you've already dialed in most of what you're looking for and you want to push further. So growers who want to enrich their A-grade factions, who want to control larf, reduce trim, this is going to work well in that space. But it's going to work well if your cultivation practices are already dialed in. ICL is a powerful tool, but it's not a silver bullet. It has to be used in conjunction with good practice. Another place where this is really helpful is where you have limitations on infrastructure, particularly power availability. Because these are delivering directly in the canopy, you're able to deliver light very efficiently. And you're also able to dilute that light out. So you can add light into the canopy with a relatively low amount of available power. And you can deliver it where it counts. This is also a scenario when it's difficult to change your top lighting because of either weight restrictions or because you're already quite content with the top light that you have. However, we do recommend that if you can optimize top lighting, that you do that first and then look at ICL as an add-on. We're going to pivot and we're going to talk to a grower about his experience. So I want to introduce Mike. I'll have Mike on in just a second. I met Mike this winter. Mike is a New York grower. He works in hoop houses, and his farm is called Echo Creek Farms. As I mentioned, I met Mike in January in mid-New York. So here's a photo of my first visit. You'll notice it's cold, it's snowy. But when you walk inside and you look at his crop, take a look at those colas. They're like the size of my fist. And it was just 100 feet of that. So, and when we zoom in, you can see that there's really good trichome development on these as well. So I want to take a moment and acknowledge that Mike is achieving phenomenal results, and he's achieving those results in a very challenging climate. So I just wanted to acknowledge that Mike is a very talented grower.
Thank you, Jason.
Yep. Hey, Mike, one sec. I'm going to throw this up just real quick for everybody too. So before I let Mike take over, I just want to introduce the trial layout that we had here real quick. So in Mike's design, the first thing we did is we did an HPS retrofit. So we changed out HPS the top light with our Vipers that about doubled his light on canopy. And then the next trial that we started running, we moved about 200 ppfd of light from the top light into the inner canopy. And you can kind of see here where you have fewer raptors on the top to the right than you do on the left. So as we talk about the layout, this is what we're talking about. So anyways, hey, Mike.
Hey, thank you. Thank you. It's been fun to be part of the trial.
How about you give us a second here to just talk a little bit about your background and how you got started in cannabis?
Yep, I haven't always been in agriculture. Was previously in the restaurant business, owner, chef, and was looking for a career change about 12 years back, and always had an interest in ag, and that kind of led into starting Echo Creek Farm and overlapping the restaurant and the farm for a few years, and transition into the farm, mainly selling locally, but a lot of it was sold in New York City for about 8 years, and it's a 4-hour trip from us. So was looking to get out of the city and didn't quite know what would transition that market to replace the New York City market. Didn't have cannabis on the radar, but then was approached by a AUCC hemp farmer that when legalization happened in New York, he was interested in contracting us to grow in greenhouses that first season. And my wife and I thought that might have been that avenue that would have been a good opportunity to do that would get us out of the city markets.
Cool. So if you're going to work with a contract grower, why would a licensed operator want to work with you instead of growing their own product?
I think a lot of the hemp farmers at the time didn't have much infrastructure. So just for solely starting plants alone in a propagation house was beneficial, but he also knew that that's the direction he was heading and wanted to get that experience the first year with growing. He was hands-on with the operation and growing in greenhouses that year, and try to cash flow into the second year to build some greenhouses and move along in the industry that way.
Is there something about the infrastructure that you have in place that puts you in a good position?
Yeah, I mean, I think we had decent. Well, I think we have really good vegetable infrastructure. It was automated roll-up sides, automated irrigation, automated a lot of it. So we grew a first-year crop. We grew 3,000 square foot greenhouses for him, and had a good crop. But it was definitely a learning experience the first year, and which kind of led into the second year.
So what were some of those lessons learned?
Well, definitely lesson learned was vegetable infrastructure isn't necessarily great cannabis infrastructure. So going into year 2, it was a little bit of a slow rollout in New York. So in a little bit of a sense that it was an advantage to me, because that license holder wanted to stick around and then kind of retry year 1. And I also gained another contracted grower that year. So, but going into year 2, we did those upgrades. It was definitely more atmosphere control, adding some Quest dehumidifiers, intake, outtake fans, light depth in the greenhouses, so you don't have 3 greenhouses coming in at one time. And then the other big move was the license holder was only allowed maximum 20 lights at the time, but we took a small greenhouse and did a light depth remodel on that and maximized the lights in that greenhouse to get that experience of growing with light deprivation, and kind of 4Xing your experience in 1 year instead of just growing a 1 main season crop. So.
And that first upgrade was HPS?
That first grade was HPS, yeah.
Okay. So out of all those upgrades, what would you say was the most critical?
I mean, putting it all together is, but the lights in general, the quality, your days to maturity were right on point. The multiple crops in 1 year were right there. THC levels were a little higher than the sun-grown greenhouses. So in general, more light, the better for us.
So I'm curious then. So when you got those HPS in, you had a turn, things were looking good, and then you looked at doing an LED trial. What drove interest in LED top lighting, and what concerns did you have going into that trial?
LED. So I was contracted, and the license holder was looking to, at this point, no, the following year to build a couple of greenhouses, and he wanted to go the LED route. So he approached me and said, "Do you want to try them in here? We'll get the experience on the smaller scale greenhouse." And I didn't have any concerns at the top lighting at that point. I knew it would be the way the industry's going, in a sense, a little less power consumption, or and a little bit less labor. Actually, we were switching from metal highlights to high sodium bulbs between runs, kind of adjusting the heights of the high pressure sodium. So a little bit less labor, and thought it was all worth a try.
So when we came to you, then you're all settled in, you've had HPS, then you had top light LED, things are banging, and we show up and we say, "Hey, Mike, how about we make some more changes and stick some lights in the middle of your canopy?" What did you think about that?
Yeah, I was on board for it, but I did have a little concerns on interlight canopy. I'm definitely trying to like maximize the square footage of that greenhouse to the full potential before, in a sense, building another greenhouse and trying to get equal of what I had. So we're organic, soil grown, 10-gallon pots, and I thought maybe just a little bit of nuisance dealing with top dressing. Sometimes we're automated irrigation, but we're hand watering in on some top dressings weekly. PMI trellis. Sometimes we're 3 layers of trellis on a cultivar. So just kind of the nuisance of daily operations, taking it down, the rebuild between turns were my our initial concerns. But in knowing that we are limited power on the farm, it was worth a try to see if I can get the same yield quality for a little bit less power.
And how did it work out?
It worked out pretty good. I think we came up with a design to when we built the Intercanopy light that really kind of canceled out all of my concerns. We had I can go into the design, I think, if you want to.
Yeah, I pulled up some photos for you.
Okay. So the design, it was kind of canceled out, like I said, the initial concerns. We're trying to be as efficient as possible, and even on transition and of the greenhouse turnover. When we harvest, we have the same the same day I have 180 plants in there going back into veg to do the next run on that tunnel. And so the design was, we kind of put, well, we didn't kind of, we put permanent 2-inch steel post on each end of the bed, and kind of had the lights hung on a high tensile wire that was a permanent fixture. So when they were there, they were always hung. And tighten that as hard as we can, it would it stayed there, but it still had a little sag. So we added 4 adjustable light holders from purlin to the wire, and that gave it the an even, you were able to pull the sag up wherever you wanted and hold it into place. And it also wasn't the plan originally, but it added a benefit of, if you loosened that high tensile wire, it actually gave 18 inches to almost 2 feet of play in that interlight canopy. So you can fine tune those adjustable wires to kind of wind up the interlight canopy where you want it at any point. So the top dressing was super easy. It wasn't in the bottom of like bottom light, and it wasn't in the way of top dressing and hand watering in the occasional times that we would do that. And then trellising was next concern. So ideally, I thought it would, sometimes I'm trellising, most of the time I'm trellising by myself on that one. We thought, maybe somebody would have to hold the lights up with 2 hands as you run the trellis over, and then intermingle some wires through the trellis. But since the lights were on a permanent fixed cable, I just had to unclip two of the adjustable lines, put the trellis over, reconnect that, and do that 4 times. So one person could do it easily. And yeah, so, and then the last concern would have been harvest on turning over the greenhouse. Again, the trellis, we just had to disconnect the adjustable line, so they the trellis came off easy, and then replanting it, we were 3 beds on a 5-foot 3 rows on a 5-foot bed. So even like transplanting that middle row with the lights in the way, we were just able to release enough slack on the high tensile and pull it up 2 feet and transfer them without them ever being dismantled or taken down. So we're on the second run with the vine light, and it didn't come apart, and it was really no nuisance from the whole time. And the benefits seem to be, we don't have the final results yet, but on the wet weight seemed to be right there.
Let's talk a little bit about the yield results. So that how did things change from HBS to LED and then from LED to vine?
Yeah, I mean, a constant. We're obviously starting from the main season sun grown to HB was a transition up, and then we had switched over to the LED, which was great. There was the whole path has kind of been a increase of yield, not just a little bit, but a substantial increase between step to step. It's the first one of HBS is to LEDs was a little bit of a weird grow because the lights came maybe a week into flower, so it was a transition. But it was still up about 20 or 12 pounds that run from the previous HP. And then the second one was they were able to veg under LEDs and flower that whole time, and that was pretty much a double yield from the original HPS. Cutting out the middle, the first LED transition there. So, and then add in the interlight canopy again, the same thing. Like quality was right there. That we don't have the final density of the middle kind of buds yet. You guys are coming to do some measurements and density tests, but like just visually looking at it, you could kind of like show people and say, check out the center of that canopy. You know, you can see the difference there. And like you said, it was a little bit less light on one side to the other. So we so in the wet weight came in within pounds apart, and we were running the same cultivar during all these runs, so it wasn't necessarily things changing on that. So the wet weight of the final run with about 13 to 15% less light on the top light on one side with the Intercanopy Lighting came in at the same, and we're coming up with the final numbers at the end of the month here.
Great. Well, Mike, I want to thank you for taking a moment to chat with us and share your thoughts. I guess as we wrap up here, I'm looking forward to coming out and collecting that data with you. But I want to thank you for taking the time to chat with us. With that, I'm going to turn this over to Tim Kopp, and we can move into the Q&A section.
Again, guys, great presentation, great information, really thought-provoking, to be honest. We do have a handful of questions here that I'll get to in a second, but I wanted to mention, I noticed a handful of people with their hands up in chat. Unfortunately, in this presentation, we're unable to turn on mics. So if you did have a question, you'll see a little Q&A button at the kind of right center of your screen. You can click that, drop a question in, and we have a good 10 minutes here for questions. So let's see what we have. First question, I guess, will be for Mike. Mike, what was the biggest challenge you had with introducing ICL into the grow? Was it deployment, hanging, working around the trellis? Was there anything specific that you found yourself struggling with?
Yeah, the initial was just coming up with the design to have just not hang them from the purlins and have these lights that then if you disconnected while you trellis, that you would need a person holding those, in a sense, those lines holding that light up. So having that stationary high tensile wire through it keeps it there permanently. So you can always have that forgiveness of putting trellis layer on and then sneaking the whatever you're using to adjust the slack. I use the adjustable light hangers. Really a lot easier than I thought it was going to be to manage. And then again, turning over the greenhouse just as equally easy to have them kept in place, and they're right where they were for the next run.
Great to hear. And I heard you mentioned, before being a cannabis cultivator, you grew kind of traditional commercial ag crops. Any big difference between cannabis and your other crops you were growing in the past, or is it just another plant, or is it easier maybe or harder?
the most a really high end tomato greenhouse can be probably as equally labor intensive and as finicky as adjusting pH and on point fertility. Though yeah, it's the most challenging one. It's fun to work with because I think it's just you can push. I don't think we've pushed we haven't pushed the limits to it yet, and definitely I think you could do. I treat things a little bit more like a vegetable in my knowledge of coming from pruning tomatoes and stuff like that and fertility. But yeah, I think it's got a whole nother level to of labor intensive, but and joy of working with.
I want to hop in real quick on the hanging side of things and say that for those who are in the audience who are growing indoors on rolling benches or other technologies, that we've actually developed some approaches that have some of the same features as Mike's operation, but that would work with the trellis posts that you might put in on a rolling bench. So if you do have questions about those or you're interested in those applications, there are some solutions that have been worked up for indoor growers as well.
Thank you both. Some more questions, actually a lot of questions starting to roll in. I thought this was a good one too, because this is something I often wonder about. Does introducing ICL affect your defoliating strategy as a grower, or can you just keep along the same old, or do you have to thin a little bit more to take advantage of the added light in the canopy? Curious of your thoughts, Jason.
Sure. So we actually have trials actively going right now that are looking specifically at that question, where we are looking at different levels of canopy density or planting density and understanding just how far we can push it. That being said, anecdotally, here's what I got. First, you can't just let the crop run. I don't think that'll work. Right? If you have a very dense crop, very impermeable to light and to air, then one, you're going to have issues from other things like moisture management and CO2 gas exchange. Right? If you don't have CO2 in the canopy, it doesn't matter how much light you add. There's nothing to fuel photosynthesis. So you still need good canopy management for other reasons. The other thing is that it is still light, and so we do want that light to get to other bud sites. And if you overwhelm it with leaves, then that light is going to get trapped and it's not going to do its job. So there is a need to manage canopy density to a degree, so that you are getting penetration throughout the space. It's one of the advantages of intercanopy lighting is the ability to hang multiple sticks so that you are distributing that light even further through the vertical profile of the canopy. That being said, I do have some anecdotal findings that showed that there's a little bit more forgiveness to being a little bit lighter on your canopy. Maybe not quite so much defoliation as is necessary in top light. Also a little bit more forgiveness in the timing. Sometimes it's hard to get in and do a whole room, particularly a large room with a limited staff, and to do it quickly. And so a week might go by, and in a top light scenario, the impact of that timing can be pretty considerable because your plants grow quickly, they can shade buds very quickly. Intercanopy can buy you the time to get through and get that done over that period without seeing substantial consequences.
Fantastic.
Well,
I think
I
this
want to
is
jump in on that a little bit too there, Jason. Because in my experience, we grow a pretty dense canopy at Texas Original, and that was, one of the locations where we didn't see an effect. One of the things we're working on right now also is a plant density by intercanopy experiment to see, is there an effect? Is it better to have a dense canopy or a less dense canopy? Is it better to have those leaves absorbing all of that or letting the light inside the canopy move around a little bit? So I think there's still a lot to learn about what's the optimal. And to say also, we've seen it work with a range of different pruning strategies and density strategies.
excellent. Perhaps a good question for Dr. Dave. It says, other people are saying that light use efficacy is better with ICL than your traditional top light. Why might your conclusions be different?
Right. Yeah. Okay. I've heard different versions of this question from growers and other folks in the industry. Another way to say it is basically people are saying that intercanopy is giving you kind of like this disproportionate enhancement to yield. By redistributing the same total amount of energy, you're getting like, dramatic increases in yield versus just doing top light. I would say that we've seen that in a couple cultivars, but that is outside of the norm. And obviously, I can't speak to how other people are executing the research, but what I would say is one of the things or one of the challenges we kind of bumped up against when we were designing our studies is like, how do we make sure we normalize the total amount of energy that we're putting into the crop? And that's kind of hard with intercanopy light, especially from a research standpoint. When we're talking about like top lighting, whether we're doing like a spectrum study or an intensity study, the standard practice in the way that everybody does it is you measure the photosynthetic photon flux density at top of canopy, and you assume a reasonably homogeneous sort of calculation plane. And you say, well, at top of canopy, I'm getting 1,000 micromoles or whatever. And we're all good with that. When it comes to intercanopy, you don't really have the opportunity to make that same assumption, right? Your light is down in the canopy, and it's not like you have a clearly defined calculation plane. It could be argued with tomato and cucumber, maybe, where you have kind of these walls of leaves. You could use that as your calculation plane, but for something like cannabis, you can't really do that, right? You might have, like, if this is your light and then you're measuring here, that might be true right there. But then as you kind of move up or down, it's going to fall off really different. So the way that we did our research was we looked not at photosynthetic photon flux density, but just PPF, or photon flux density. And that's quantifying all of the light, the total light coming out of your fixture. And then we assume that with intercanopy light, especially with these dense canopies, we make the assumption that 100% of that light is being captured. Obviously, that's not perfect, because if you are seeing the light, that means that sunlight is getting to your eyes and not the plant. But for intercanopy light, it's what we believe to be the most fair way to assess whether or not this redistribution of energy is keeping yield the same, if it's enhancing yield, if it's inhibiting yield. So all of that to say, when I hear other lighting providers say they've found a way of sort of disproportionately enhancing yield, in other words, achieving a much greater light use efficiency, I question a little bit how they quantified the amount of light they were applying, just because we've done so many trials at this point that, and we're not seeing that very consistently, that I'm a little bit skeptical, but I always invite more research and dig in where possible. I'll put it that way. And I'll let us move on. But I will say again, like, cannabis is a really different animal than cucumber. I kind of started the talk that way by saying in cucumber, you do get that disproportionate enhancement because that crop can't take light the way cannabis can, right? The top of that canopy does get saturated. So by moving light in the canopy, you do get a disproportionate enhancement of yield. Cannabis, no, it's just very happy to have light no matter where you put it, for the most part. I hope that helped.
It does. It
Hey,
does.
Tim, I see a question from a gentleman named John Ertl asking about photo bleaching that we saw in one of the experiments. I think that was a photo that Brian showed. So, John, you asked what was causing the photo bleaching in the experiment, and theorizing about whether that was the increased photon flux or heat. And actually, I think it's more a result of the spectrum. If you take a look back at Brian's slides, he was talking about using different spectra inside of the inner canopy, and the bleaching was occurring in the high red spectra that we were using. We've released a pretty considerable amount of research showing that red light is strongly associated with photo bleaching and cannabis. In this case, what you'll see is that the bleaching was occurring in the very high red treatment. Also, we've noticed that when you have discrete red diodes, that nugs that are sitting right on that or right by that red diode will bleach locally right around where it is. But you can actually have flowers that are sitting up against the white diodes in that same bar, and there'll be absolutely no change. So same amount of heat production, same amount of flux from the LED, roughly. Really, the underlying cause is exposure to a high intensity red light.
Excellent. Great answer. Thank you, Jason. We're running out of time, but I want to get to one more. I've seen a lot of questions off to the side about cultivars. Are there particular cultivars that seem to respond better to ICL, whether it be a tropical strain or one that's more high elevation? Any thoughts or conclusions on this being a strain-specific application?
Yeah, I can
Okay.
grab that one.
Yeah, take that, and then I'll follow.
Yeah, I mean, there's so many different kind of backgrounds to say, hey, this this is sativa, this is an indica, where it's originally or its origin, and it's so hard to tell because we kind of see these conflicting results. It's really the reason why we have this grower outreach is because we can't test every cultivar internally. The other thing we can do is we can work with actual breeding companies themselves and say, hey, how do these react? Try to get an idea of these plants' backgrounds and see if we can infer some sort of trends in these. But I think at this point, because there's such a wide array of things to work with, it's really difficult to get in that direction.
I'd say
Jason? Yeah.
from my conversations with our participating partners and kind of what we've done at Texas OG, that there's a little bit of grower intuition that can be used. So strain, we all know there's some cultivars that just grow. They grow the way that they grow, and you get what you get. And Blue Dream is sort of in the realm of that strain. She goes very well under a wide range of conditions, and rides sort of a middle ground of sensitive to challenging, which makes her a great study cultivar. But as growers who've worked with Blue Dream for a long time know, there's a fair amount of resilience. There are strains that are substantially more sensitive to environment or other conditions than Blue Dream. And there's strains that are even more resilient. Doesn't seem to matter what you do to them. They're going to grow really tight nugs. So what we kind of saw with some of our participating partners is that in cultivars that were already sensitive to your lighting environments or delayed defoliation, where if you didn't quite get it right, you're going to get larvae. Those strains responded very strongly to ICL. Cultivars that were less sensitive to those inputs weren't as sensitive to the ICL. So it really comes down to saying it works best with some of your fussiest strains. And so if you're trying to look for a troubleshooting method of saying, how do I keep this girl who does really great in the market, but is really hard to grow because she's fussy? How do I keep her in rotation? ICL might be a solution there.
Interesting.
Yeah, and I think I'll weigh in. I'll try to be quick because I know people have stuff to do. But this is actually kind of part of the ongoing research effort, where we know obviously there's cultivar dependency, and a big part of what we do, regardless of the crop we're talking about, is we spend a lot of time thinking, why do some cultivars respond better to XYZ lighting solutions compared to others? In the case of cannabis and intercanopy lighting, something that we've been poking around with is, maybe planting density is a thing, maybe pruning strategy is a thing. Like the overall crop architecture inherent to different cultivars or cultivation methods could have implications for what kind of benefit you see with intercanopy. And one of the great ironies of cannabis from a research perspective is that it's arguably one of the more interesting plants to work on, but because of the genetic diversity that exists compared to other commercial crops, it's so diverse that the way it responds to a given environment input tends to be kind of all over the place. And that's kind of why, like you saw Jason earlier, he was presenting his meta-analysis to say overall, across all of these studies and these case studies that we have commercially, this is what we see on average. But in the weeks and months and years ahead, we will continue to explore this so that over time we can even more explicitly define, this is what's going on, this is how it works, and therefore this is how you should use this tool.
Awesome. I think we will leave that as our conclusion for today, or our final point, that is. Big thanks again, Mike, for joining us and the rest of the team here. Loved having you, loved hearing your story. Likewise to the crop science team, very well done, fascinating, still a lot to learn, for sure. There's still a lot of questions kind of being bounced here in chat kind of last minute, so I want to make sure that we're able to address those questions. So if you have further questions, You can reach us out to us on fluence-led.com. There's a big contact us button at the top of the page, or you can even email us directly at support@fluence-led.com. Likewise, you can probably find most of our presenters on LinkedIn or social otherwise. I'm sure they'll be happy to answer your questions there. But otherwise, excited to see where ICL and ICL strategies go from here. So thanks again, guys. Great presentation. And we'll see you on the other side.
Thank you, guys.
All right. Thanks, everyone.
Thanks all.
Have a good afternoon.